All right, are you guys ready for one of my all-time favorite subjects? Calculus! Okay, just kidding. But we're moving on and we're going to be talking about related rates today. So this is just kind of an intro video to kind of let you know what it is, how it works, whatever, why we have it. So we're going to talk about this example. When we are blowing up a balloon, what changes on that balloon? So obviously, as you blow up a balloon, it is going to increase in volume, right? And then we could say like the height of the balloon changes, kind of like height-wise this, and maybe even its width that way. Surface area is going to change, and all that, right? We could kind of keep going with our list, but that's a pretty solid list for now. So we're just kind of thinking of like a balloon that looks something like this, yeah? Whee, cute little balloon there as I blow it up. So height, width, volume in general, and surface area of that balloon is changing over time. Okay, so like as you're blowing up that balloon, time is changing, and each one of these is changing at different rates, but the thing that they have in common here is time. So we're going to write this here. They all change with respect to time. We all know that when you start to blow up a balloon, like the volume increases really quick, which means everything's changing really fast. And as that balloon gets bigger, all of that change slows down. They still have their own rate, but it changes over time depending on how big that balloon is. So when we're talking about the volume of a balloon changing, it's changing with respect to time. Okay? So we're going to write that as dV dt. The change in volume over the change in time. That's the rate of change of the volume. Well, as the volume's changing, so is the height. So the height has its own rate of change. Width and surface area are the same. So my width is going to change and my surface area is going to change. But they all are changing with respect to time. Okay, so they kind of work together, but depending on what time we're looking at is going to give us different rates for different things. But all of these rates work together because it's happening at the same time. Again, another example would be to think about riding a bike. As you pedal, you're pedaling at a certain rate, and then as you pedal, the chain is changing, right? It starts to rotate, and that rotation changes the tires. And as your rate increases, so does the rate of the chain and the rate of the tires. You slow down, so do the others. These rates all work together, and they are changing with respect to time. So I'm going to come in with a couple of examples. Hopefully this kind of intros it in nicely. Let me know if not. And let's take a look at some more examples.